All right, so in this video, we're talking about, writing equations of lines that are parallel and perpendicular to a given line passing through a point. Now, generally speaking, we'll be writing in these three forms. Okay, the slope-intercept form, the point-slope form, and the standard form. Okay, there are actually more forms like the intercept form and all that, but, let's use these. I think these ones are the most common. So first of all, we have the slope-intercept form where it's y equals mx plus c, or y equals mx plus b, depending on where you are. Some will use c as their intercept, some will use b. Okay, it's the same thing. Your m is your slope, so m, hence the name slope-intercept form. So slope and then intercept, specifically the y-intercept. Okay, now for the point slope form, it looks something like this. We have y equals, sorry, we have y minus y1 equals m in bracket x minus x1. So these y1 and then your x1, these are your points. Okay, these are your points, and then your m is your slope, hence the name point slope form. And then for the standard form is, fairly ax plus by equals c. It just means that, the variables are on one side and then the constant is just on the other side. Just as what, and then your a has to be, a positive value. So if you whole numbers, so a, b, and c should be whole numbers. Okay, whole numbers. And then a specifically has to be a positive integer, positive value or integer. Okay, we'll talk about that as we go. Now let's answer this question. Write the equation, write the equation of a line that is parallel to y equals 2x. So let me write it out. So we have parallel to y equals 2x plus 3 and passes through 4, 3. All right, so we're looking for a line that's parallel to this and that is passing through 4, 3. So for two lines to be parallel, I think I typed it somewhere down here, just, yeah. So for two lines to be parallel, their slopes or gradients are equal, okay? Or you see something like m1 equals m2. All right, so it means that the slope of this line and the slope of the line that we're looking for are the same. All right, so if the gradient of the slope of this line is 2, the slope of the other line is also 2. So we have something, so we've gotten something, so we can say, oh, okay, slope of the line equals 2 since they are parallel. This is just, if you're maybe writing an exam, something you can just write so that the person who is, looking at what you're doing also, oh, this person knows what he or she is saying. It's not necessary, but yeah, so the slope of the line is equal to 2, or you can say m2 is equal to 2, and how you want to write it. Now, how do we now find the equation itself? So this is where the point slope form comes in. Okay, where we have y minus y1 equals m bracket x minus x1. So we know that our slope is already 2. We've established that. So this is going to be 2. Use a different pen. It's going to be 2 because it's parallel. And then our y1 and x1. So these are our points. This is where these will now come in. So our x1 is going to be 4. Our y1 is going to be 3. Okay. We just put these values inside. So we have y minus 3 equals 2 brackets x minus 4. Okay, we open the bracket. We have y minus 3 equals 2x plus 8. Okay, we want to do it in slope-intercept form. So it means that y should be alone. All right, so we have to move this -3 to the other side. Okay, and once we do that, it's going to become plus 3. So now this now becomes y, sorry, let me use black now. Y equals 2x plus, oh, sorry, my bad, minus 8. Okay, 2x minus 8. I'm so sorry for that. 2x minus 8. Okay, plus 3. So this, in the end, this will give us y equals 2x minus 5. Right, so our answer, so it means that, okay, 2x minus 5 is parallel to, let me get, so 2x minus 5 is parallel to 2x plus 3 and passes through 4, 3. And I think we can use, there's this, if you use Desmos, they have this graphing calculator. You can actually check that. So let me see if I can actually share that on my screen now. We just as a form of proof. So let me see if I can share that. I think this is it. Okay, so if we compare 2x plus 3 here and we compare 2x minus 5, you can see that both lines are parallel. Okay, 2x minus 5 is the blue line. And then 4, 3, we can see it actually passes through 4, 3. If I can annotate here, 4 on the x-axis and then 3 on the y-axis. So our answer is actually correct. Okay, just to show that, this just as a form of confirmation. All right, so I think we can move on. Let's go to the next one. Still the same question. Let's go up. Now, equation of a line that's perpendicular to y equals to, so the same line, just now we're talking about perpendicular. Okay, same line, but we're not talking about perpendicular. So let me just copy this down here so we can just focus on it. Right, we want to know the equation of a line that's perpendicular to y equals 2x plus 3 and passes through 4, 1. Now, for two lines, so we have y equals 2x plus 3. So again, the gradient is 2, or the slope is 2. Now, for two lines to be perpendicular, okay, m1 times m2 is equal to -1. So it means that if you multiply the slope of the first line and the slope of the second line, it should give you -1. Or you could also write like this. You could divide both sides by m2. Okay, this cancels out. So m1 is equal to -1 over m2. So whichever way you want to do it, you can write it like this or like this. You could still divide both sides by m1 and say m2 is equal to -1 over m1. All right, so we know that the slope of this first line is 2. So it means that let's say m1 is equal to 2. m2, we don't know. So it means that 2 times m1, or sorry, m2 rather, is equal to -1. Divide both sides by 2. m2 is equal to -half. So it means that the slope that we're looking for, okay, the line that we're looking for has a slope of -half. So the line has a slope of -half. All right. Again, we use the slope at the point slope form to now find the equation of the line. We know that y minus y1 equals m bracket x minus x1. Okay, we've gotten our slope, which is -half. All right. And then for our points, if we look at the question, passing through 4, 1. So our x1 is 4. So 4, 1. This will be our x1, y1. So this would be y minus 1 equals negative half bracket x minus 4. Okay, so let's continue. We have y minus 1 equals, to open the bracket, so you can write now negative half times x. You can write it as you can just write negative half x or negative x over 2. Yeah, it's the same thing, but let's just go with, because we want the slope to show, so we just write it as negative half x, and then negative half times negative 4, that becomes plus. Okay, so 4 divided by 2, that will be 2. Okay, negative half times negative 4, that will give us 2. Remember, we want y to be alone, so we can move this negative 1 to the other side, and it becomes plus 1. So now we have y equals negative half x plus 2 plus 1. Okay, so 2 plus 1 is 3, obviously. So it means that y equals negative half x plus 3. So this is how the equation will look like. So this is the equation of the line that we're looking for. Okay, y equals negative half x times 3. Now, if we want to, what if we want to express it in standard form? Okay, just what if we want to express it in standard form? Because sometimes they could ask you, express it in standard form. So to do that, we just have to move this. First of all, we can move this negative half x to the other side. Okay, so let me just draw like a dashed line. So this is actually our answer, but let's just also express it in standard form. Um, so we have y plus half x equals 3. Okay, but we want x to be, we want x to come first. So let's rewrite it as half x plus y equals 3. So good so far, good so far. So remember, we want, the coefficient of x and y to be whole numbers. So a fraction is not just going to do it. So what can we do? We can multiply both sides by 2. Because if you do that, it cancels out this 1 over 2. So let me use a green pen now. So multiply both sides by 2. 3 times 2. Okay, once we do that, this gives us x plus 2y equals 6. If we open the bracket, so x plus 2y equals 6. And this will be our answer. So in slope intercept form, our answer is like this. In standard form, we have x plus 2y equals 6. Let's actually test if this is true. Okay, let's test if this is true again. We can use the graphing calculator. So let me come here and share my screen again. Uh, okay, so this was the one we had before. I haven't removed it. Let me now add the new one. So our answer we got was negative half x plus 3. So let's see. So negative half x plus 3. Okay, let me annotate. Right, we can see that these lines are perpendicular. We're focusing on let me remove this other one first just to avoid confusion. So focusing on this one. So you can see they are perpendicular and it passes through. Let's see, does it pass through 4, 1? So I think where it was going to pass through before was 4, 1. 4 on the, okay, let's see, this is 4 on the x-axis, and this is going to be 1 on the y-axis. So as you can see, it actually passes through 4, 1. Okay, and now let me now do the third line, the third one, the standard form. So let's see if it's actually the same as this one. So we had x plus 2y equals 6. You can see now the purple line is kind of overshadowing the line that was there before. So they actually are the same thing. So slope intercept form or standard form, whichever you're comfortable with. So if I delete this, you can see it turns back to green. If I write it back, so x plus 2y equals 6. Let's see. All right, let me clear all this. Let me clear all this. Um, okay, I'll come back here. So we've done a lot now. I don't want this video to be too long, but there are still more questions down. Perhaps you could try. Okay, here's what I would do. You could try this on your own. Okay, try this on your own. And let me see. Okay, try this, and if you have any problems, you can, let me know in the comments. I might have to answer that again. But let's go to this true or false, something a bit stimulating too. True or false? Now, y minus x is parallel, y equals x minus 5 is parallel to y equals 5 minus x. Are they parallel? So let's actually see. Y equals x minus 5. Then we have y equals 5 minus x. We can actually write this in slope intercept form. We want the x to come first. So this will now be y equals minus x plus 5. We still have y equals x minus 5. Now, are they the same? No, they're not the same. Okay, they're not parallel. Why? Because the coefficient of x are not the same. The coefficient of x here is 1, okay? But the coefficient of x here is -1. So these two are not the same in any way. Like they're not parallel. Sorry, okay. Are they parallel? No. Okay. So they're not parallel at all. If you think about it, they could actually be perpendicular because 1 times -1 is actually -1. So these lines are actually perpendicular, not even parallel. Wow. I actually didn't think about this when I made the question, but that's nice. So these lines are actually perpendicular. So why? All right. Let me answer number 2. Um, 4x minus 2y equals 9 is parallel to. So you can see now these are in standard form. Now, are the slopes, for them to be parallel, you know that the slopes are equal. Okay, the slopes are equal, right? So yeah, the slopes are equal, and we can actually get the slopes directly. Okay, so instead of changing it, so you can actually change this to slope intercept form. Okay, it changes to y equals mx plus b, and then get the slope from there. But there's a kind of a quick way to get the slope directly. All right, which is all right for the standard form, which is ax plus bx equals c. The slope of this will be negative a over b. Okay, negative a over b. That will be the slope. That will be a quick way to get the slope. So let's see. For 4x minus 2 equals 9. So our a is 4, and our b is -2. So this will be -4 over our b is -2. 4 divided by 2 is obviously negative cancels out. 4 divided by 2 is 2. So the slope of this is 2. And then for 2x plus y equals 4, again, our a is negative a over b. Okay, so we have -2 All right, so A is 2, negative 2 over, what is our B? So the coefficient of Y here is just 1. Okay, coefficient of Y is 1. All right, so negative 2 divided by 1 is negative 2. So they are not parallel to each other. Okay, they're not parallel to each other at all. So these slopes are not equal. If the slopes were the same, then, yeah, but the slopes are not the same. So it's not going to work here. Only if it was, let's say, 2x minus y, aha, but the slopes of this are not equal. Let's even check. Now let's check the Desmos graph just to be sure. Okay, so let me share. So let me share my screen again. Okay, let me cancel all these ones. I think we're done with all these. This, and this. So the first one is 4x minus 2y equals 9. 4x minus 2y equals 9. And the second one is 2x plus y equals 4. 2x plus y equals 4. You can see they're not parallel to each other. Okay, they're not parallel to each other. But assuming we had 2x minus y equals 4, I think that could have worked. Sorry. Yeah, I think that could have worked. They would have been parallel to each other, but 2x plus y equals 4, they're not parallel to each other. So just something you can use this to practice. Again, now, because of time, I don't want to take too much time on this video. Um, you could try this by yourself. So here's what I would do. I think um, answer put your answers in the comments, and the person who answers first and puts I'm gonna pin your comment and say it's correct. I wish I could think of something to do, like maybe, but I think I'll just write your answers in the comments, and if it's the correct one, let's say, I think the first three people, the first three people, I'll most likely pin the first one, but I'll also reply to the other people, like next two who answer the questions correctly. But if you have any questions on this, you can always let me know in the comments. Thank you and have a nice day.